Hi guys, today we are going to know about the projection of points, which plays a vital role in engineering graphics. So in the present figure, we can observe the two planes. Generally, we have a single plane, and that particular single plane, it has been represented in terms of the two planes, that is the vertical plane and the horizontal plane. And in the present figure, if we observe the two planes, the HP as well as the VP, both the thing has been intersected on a particular region, and it will be notated as an X and the Y, and it will be termed as a reference line. And the two planes, it has been splitted in terms of four equal parts of a particular plane, and each and every part will be termed as quadrant. And now where these parts will be referred as a first quadrant, second quadrant, third quadrant, and as well as a fourth quadrant. And moreover, we don't have any more proofs that why we need to start the first quadrant from this part and it has to be succeeded. So we can place any more as per our convenience. It's only a tradition that why we are going to place this as a first quadrant, second, third, and the fourth quadrants. So majorly we are going to use the first quadrant and the third quadrant itself for projecting the projections of an object, but not on the second and the fourth because of its complexity. Now we are going to place an observer on the first quadrant. In the sense, we are going to fix the observer in the quadrant 1 itself. Whenever the observer starts moving from one to the next, then each quadrant will be defined as a first quadrant itself. And moreover, the front view which will be projected on the vertical plane and the top view which will be projected on the horizontal plane, it also decides with the help of an observer point of view itself. In the sense, whatever we are going to define in the projection of the points, it purely depends on the observer. So now we are going to get the pictorial representation of these planes in terms of a single plane while observing in this particular direction. So now this was a single plane, and we are going to define the vertical plane in terms of in this manner and the horizontal plane in terms of in this way. There's a reason that what we stated initially, where this was a representation of a single plane. So, and this was a point which will be defined as the XY, which is the reference line. So vertical plane and horizontal plane, and the observer supposed to stay on the quadrant 1 itself, defined as the first quadrant and second and the third as well as the fourth quadrant. So now we are going to define the notations for the front view, top view as well as the side view. So the top view has to be represented in terms of a small letters. If the object will be defined as a capital A, then the top view will be defined as a small a. If the object has been defined with a capital AB, then the top view has to be defined with a small ab. And the front view will be represented as a, for the A, it should be defined as a dash, and for the AB, it should be defined as a dash B dash. And similarly, for the side view, for the A, it should be referred as a double dash, and for the AB, it should be defined as a small a double dash and B double dash. And now we can get a clear thing here, as the object has been defined with a capital letter, and we are going to make the notations of the front view, top view as well as the side view with a lowercase and moreover with the help of a dashes. So what we are going to define here in the sense, it's not the object that what we are going to change, but it's only the object when we start projecting. In the sense, when the observer looks over the particular object, it may be in the top, it may be in the side, or it may be in the front. Whatever it has been appeared of an object with respect to planes, we are going to define with the help of these notations. There's a reason we are going to define only with the lowercase, it's not with the uppercase. If you're going to define with an uppercase, then it never says about the projection of an object, but it defines that the object itself has been changed. Now we are going to define the projections of the point A. Here the projections in the sense it's a front view as well as a top view, because as we have a two planes, horizontal plane as well as a vertical plane, so we are going to define only the the two views of an object. It's not the side view, because we don't have any profile plane. In the sense, either we don't have the left or the right profile plane, so we are going to define only the front view as well as the top view of an object. Now we are going to define the projections of a point A which has been placed in the quadrant 1, and it has been noted as a capital A because as it was a object. So now we can also define the point A is in the quadrant 1 with the help of an observer point of view. So now as the observer is in the quadrant 1, in the sense he can define that he is above the HP and he is in front of VP. Similarly, whenever the point A is placed in the same quadrant as the observer has been placed, so the point A also will be satisfied with the same terminologies that what the observer says. In the sense, the point A is also above the HP and the point A is also in front of VP. In the sense, with the help of these two terminologies, above HP and the in front of VP, this also defines that the point A is in the quadrant 1. When the observer views the point A in the front view, so the observer will get two things. One is the dimensionless object point A, and next one is the view distance with respect to horizontal plane. Let us consider a scale which has been placed in between of a point A and the horizontal plane, and we can define it was a view vertical distance. As it was a vertical distance, then definitely to place this vertical distance we need a source which is nothing but the vertical plane. We can't place the vertical distance on the horizontal plane. There's a reason why the front view it has to be ever project on the vertical plane itself. It can't be projected on the horizontal plane, because as the distance from the horizontal plane to the A, it was a vertical distance, so it has to be projected on the vertical plane itself. So now it has to be represented as a small a dash. So because when the observer views in the front view where the point A, it has been projected on the vertical plane. So as it was in a projection of a point A, so we have to mention it as a small letter a with a dash, a dash. Similarly, when the observer views on the top view, again he can get two things here. One is the dimensionless object point A, and next one is a sum of the distance from the vertical plane. So if we consider scale and if we place a distance from the vertical plane to the A, it says very clearly it was in a horizontal distance. Now to project the horizontal distance where we need a source, it's nothing but it's in a horizontal plane. We can't project the horizontal distance on the vertical plane. So forever when the observer views in the top manner, the top view which is the distance from the vertical plane which is in a horizontal distance, it has to be projected only on the horizontal plane, and it has to be noted with a small letter a. And moreover, if we observe the vertical plane and the horizontal plane, it's not in a one plane. As it is in a two planes, it may be a difficult task to get the observer in a easiest purpose. So to make it as in a single plane, so to make or to observe in a clear manner, so we need to rotate the horizontal plane 90 degrees towards an clockwise direction itself. So we can't rotate the vertical plane either towards an clockwise or towards an anti-clockwise, because if we start rotate the vertical plane either the clockwise or anti-clockwise, again the observer may feel difficulty to get the views, the front view as well as a top view. So we need to make the horizontal plane rotate towards a clockwise, that too until 90 degrees. So finally it makes to appear the front view as well as a top view in a one plane, which makes the observer to get a clear information. Similarly, we are going to define about the projections of a point A in the second quadrant. So this was the vertical plane and the horizontal plane. And now we are going to place the point A in the second quadrant. So as to define that the point A is in the second quadrant, so let me start from the observer point of view. So the observer, as he is in the first quadrant and moreover he remains stationary in the quadrant 1, and he itself defines that the vertical plane was behind to the observer and the horizontal plane was above to the observer. In the sense, the point A which lies in the second quadrant, it was behind to the observer, and the A it was above to the observer. So now to define any object which is in the quadrant 2, so we can define with the help of these two terminologies, that is behind to the VP and above to the HP. So now if we observe the projections of an point A which is placed in the quadrant 2, so the front view as well as the top view, again it lies on the vertical plane as well as the horizontal plane itself. If the observer views in the front view, again he get two things there. One is about in a point A, which is the dimensionless object, and next one it is with a few distance with respect to HP. If we consider a scale and if we place with respect to HP, so we can define it is a vertical distance. So as it is a vertical distance, it has to be projected only on the vertical plane. We can't define the vertical distance on the horizontal plane. So it has to be projected on the vertical plane itself, and it has to be projected as the notation as the small letter a with a dash as a dash. Similarly, if the observer views towards a top view, so again he gets two things. One is the dimensionless object of a point A, and next one is a distance with respect to VP. So as it is a distance with respect to VP, so he can define a horizontal distance. So as it is a horizontal distance, it has to be projected on the horizontal plane itself. But again, as it is the two planes, the HP and the VP, so now to make in a clear manner, so we have to make the two as a single plane. So as the observer is in the first quadrant, so whatever the conditions satisfied in the first quadrant, it has to be applicable for each and every quadrant. That is, in the second quadrant too, the horizontal plane, it has to be rotated towards a clockwise direction until the 90 degrees. So the horizontal plane, it has to be rotated in the clockwise direction itself, and finally it has to become as a single plane. And now the notation has to be represented as a small a, which is nothing but the top view. So now if we observe that in the second quadrant, the horizontal plane and the vertical plane, it has been laid on the above xy itself. In the sense, the both the views has been laid on the above xy itself. Similarly, so let me start knowing about the third quadrant. In the third quadrant, so now we are going to define the projections of the same point A. And to know whether the point A is in the third quadrant in terms of an observer point of view, so let me start with a few terminologies. So the terminologies are, it was below HP and it was behind VP. The reason behind this, in the sense, as the observer is in the quadrant 1, so the vertical plane was behind to the observer and the horizontal plane was below to the observer. In the sense, whatever the object which has been placed in the third quadrant, it has to be satisfied that it was behind to the observer and this was below to the observer. That's the reason that what we are going to terminalize with the behind VP and below HP. So now when we are going to observe the projections, so similarly the front view will lies on the vertical plane and the top view lies on the horizontal plane. Because if we observe the projection, so when this was a point A, so when the observer viewed in a front view, again he get two things. One was the dimensionless, and next one was it's the distance with respect to horizontal plane. So as the distance from respect to horizontal plane, it was a vertical distance. So as it was a vertical, it has to project on the vertical plane itself. Similarly, it has to be noted as the A dash. So when the observer view in the top view, again he get two things. One was the dimensionless parameter of point A, and next one is a distance with respect to VP. So as it was in a horizontal distance, so it has to project only on the horizontal plane. So now it has been represented with a small letter A. And finally, as these two are in terms of two different planes, so to make it as a single plane, in the sense to make in a clear manner, so we need to rotate the horizontal plane in the clockwise direction itself. Because as the observer located in the first quadrant, so whatever the conditions satisfied in the first quadrant, it should be applicable to all of the remaining quadrants. So the horizontal plane in the third quadrant, it has to rotate in the clockwise direction, and finally the two things, the VP and the HP, has been located in a one single plane. And moreover, so the top view has been placed above the XY and the front view has been placed below to the XY, which was vice versa to the first quadrant. So in the first quadrant, the front view has been laid above the xy and the top view has been laid below to the xy. Similarly, let me start knowing about the fourth quadrant, the projections of a point A in the fourth quadrant. So now we can also define with the help of an observer point of view. So the observer, as he is in the first quadrant, so it says very clearly the horizontal plane was below to the observer and the vertical plane was in front to the observer. So here the point A also defines with the similar things as it is in the fourth quadrant. So the point A was in front of the VP and below to the HP. So this was a consideration which has been given by the observer. So if we get the projections of a point A in the fourth quadrant, so we get the similar thing. The top view has to be lie in the horizontal plane and the front view has to be projected on the vertical plane itself. So when the observer view in the front view, he get again the two things. One is the dimensionless parameter A and next one it's a distance with respect to HP. So as it was a vertical distance, it has to be projected only on the vertical plane itself. So the front view projected on the vertical plane. So it has to be notated as the A dash. Similarly, when he observed in the top view, so again he get two things. One is the dimensionless parameter, the point A, and next one is the distance with respect to VP. So as it is a horizontal distance, it has to be projected on the horizontal plane itself. So as it is in a two planes, now to make it as a single plane, so the observer has to apply whatever the condition has been satisfied in the first quadrant. In the sense, the horizontal plane has to rotate in a clockwise direction until the 90 degrees. Finally, the horizontal plane is start rotating towards a clockwise and these two become as a single plane and it has been notated as the A, which is the top view. So now if we observe the second quadrant and the fourth quadrant, in the second quadrant all the views has been placed above of the xy and in the fourth quadrant all the views has been placed in below to the xy. So there's a reason why these two become as a complexity, because if the views has been increased in the sense the side view, rear view and so on, so definitely everything has to be lie below to the xy as well as above to the xy itself. So it makes difficult to understand the views which has been projected above the xy as well as the below the xy. But if we observe in the first quadrant and in the third quadrant, so the views are in a different place in the sense where these are the above xy, below xy. So we can understand the views which has been projected in the 1 and the 3 in a easiest manner. So we are going to prefer only the 1 and the 3 as per it was in a convenient procedure. Finally, the projection of points clearly says one thing. The front view, it has to be represented only on the vertical plane and the top view, it has to be represented only on the horizontal plane. Whatever may be the quadrant, it may be a first, second, third and the fourth quadrant, it doesn't matter. So the front view has to be projected on the vertical plane itself and the top view has to be projected on the horizontal plane itself. So this was a consideration which has been stated in the projection of points. Thank you.